sample taken by Travis Audacity. To me, pretty sure they don't really know what they're talking about.
I'm Laura London, and this is a special quarantine edition of Speaking of Jung. Everything Jung wrote was based on an experience. Jungian psychology isn't about ideas, it's about experiences. This quarantine series is based on my personal experiences with interesting people. Joining us for the 20th edition in this series is tech entrepreneur, scientist, and researcher Deep Prasad in British Columbia, Canada. He holds a Bachelor of Applied Science in Industrial Engineering from the University of Toronto, where he was named Entrepreneurship Hatchery Fellow in 2014 and participated in the university's Startup Accelerator program. He was a top 10 finalist in the Next Einstein competition, for which he received the backing of a diverse panel of judges that included Nobel laureates, business and community leaders, and the NBA's Amar'e Stoudemire. Deep possesses a unique intersection of skills in machine learning and computer science and quantum condensed matter physics. His research is in the fields of quantum computing and quantum-adjacent technologies, and he spends time advocating for more transparency around the UAP topic, communicating the science and engineering of observed UAPs and trying to understand their underlying mechanics and nature. He's given presentations on quantum computing around the world and presented a novel technique to search for extraterrestrial technosignatures using quantum computing at the European Astronomical Society annual meeting in 2020. He was also a participant in the world's first quantum computing incubator, known as Creative Destruction Lab. This year, he will be one of the new faces at the annual Contact in the Desert conference, which will be held online from June 25th through the 28th. His workshop, Exomimicry, Anthroexology, and Locatiogenesis, Science of the Future, will be held on Saturday, June 26th from 9 to 10:30 a.m. Pacific Daylight Time, and his lecture, Integrating with Technologically Advanced Alien Species, How Do We Initiate Sustained Open Contact If They Arrive, will be presented on Sunday, June 27th from 1:15 to 2:45 p.m. Pacific. Deep will also appear on the panel Consciousness, AI, and Communication with Non-Human Intelligence, NDEs, OBEs, and the Quantum Field on Sunday, June 27th from 4 to 6:15 p.m. Pacific. Visit the Contact in the Desert registration page to get your virtual passes, and I will see you there. Please also visit the website speakingofjung.com, where you will find links to everything discussed in this episode in the show notes. This interview is being recorded on Wednesday, June 9th, 2021, through the magic of Zoom. Thank you so much for taking the time to join us today, Deep.
Thank you, Laura. It is a complete pleasure and honor to be here.
Oh, thank you. So, wow, we have a lot to talk about in a short amount of time, and I don't know where to start. I guess I want to ask you first, what drew you to this field?
It was, I think, very, very initially, it was the credibility and confusion that that was brought to me and that I experienced and felt when I read the CNN and New York Times magazine cover the fact that there was a Pentagon UFO program. It went against everything I believed to be true about UFOs, which was that there was nothing to it. So it was extremely interesting that there was a program in the first place that was looking into this subject. And then I started doing my own sort of investigations into the subject. And I concluded somewhat early on that there was a high probability that there was something to this. And that got my imagination going, that holy crap, the idea that there might be other intelligent life forms already here was such a fascinating subject and topic. Of course, I really struggled for a little while between, I would oscillate back and forth between complete debunking disbeliever to a believer for a long time. Now my bias is more towards the believing camp. I do truly believe there's something to this. It's not all just prosaic, in my opinion.
Does your interest in UAPs have anything to do with the work that you do?
Definitely.
Okay.
So when I look at the UAP observables that the Pentagon UFO program concluded, low observability, transmedium travel, instantaneous acceleration, deacceleration, the ability to travel at hypersonic velocities without a signature, and the ability to maintain positive lift without any lift systems or propulsion. All of these things can be reduced to new physics and new engineering. And now the work that I do is working with quantum computers. So the way that the two connect is you can use quantum computers to simulate these in theory in the future. Once they're more powerful, we'll be able to simulate what kinds of antimatter propulsion systems might be used in these craft, if you will, if they are craft. We'll be able to simulate things like wormholes in our own labs on quantum computers. And that will tell us how quantum information is scrambled from one end of the wormhole to the other, which would allow us to then infer whether or not you could truly use traversable wormholes for space travel as a way of interconnected highways. So, and of course, the final one other way of connecting them is that I see room for using quantum computers and quantum communication technologies as the next frontier for how we process information and communication. And so I believe that more intelligent civilizations could also quite possibly be communicating us using quantum communication technologies. And we just don't have the infrastructure yet to receive those communications.
So what is an example of quantum communication technology?
I love that question. So an example of quantum communication technologies would be the following. There is a protocol in quantum computing / quantum information. By the way, quantum information is the field that is at the intersection of computer science and quantum physics that looks at how can you process information and what are the implications of processing information using quantum mechanical systems. Now, within quantum information, there's this concept called quantum teleportation. Quantum teleportation is the ability to transmit quantum information instantaneously from any distance. So that doesn't mean, of course, that you can actually communicate communicate useful information instantaneously. It only means that you can transmit quantum information instantaneously.
Okay.
And I'll give you a very tangible example because that might seem too abstract and high level. The way that we're speaking right now, as my voice, the phonons, which are the force carrier for sound, as it gets converted into readable kinetic energy, that gets converted into electrical energy, and then information that's stored in my computer and then transmitted to you. All of this is happening at max at the speed of light, where all the information that's being transmitted is what we would call classical information. Classical information is what you get when you collapse a quantum system. Every quantum mechanical system gives you classical measurements. So the world that we live in, we are so used to what's called classical physics in terms of experiencing it. And by that, I mean classical physics describes the world of the big. When you have millions of atoms coming together or billions, macroscopic quantum systems, they behave classically. However, when you look under a microscope and you look at what each atom is doing, they're following quantum physical rules, not classical rules. And they're entirely different and they behave differently. We have to kind of rewire our brains to build intuition for these quantum mechanical systems. And so the whole world around us as we experience it is classical in nature. When we make a measurement, when you look at your screen or you hold up a physical object, they exist in definite states, whereas quantum mechanical systems exist in a superposition of multiple definite states until they're measured by a classical body or macroscopic body, if you will. So that's what I mean by classical information, information that is captured in describing these classical systems. Now, let's take a step back and talk about transmitting quantum information. So classical information, sure, you can transmit electricity, right? That current through a wire, and that represents a sound wave, that a word I've said to you, right? We can physically transport that current that's carrying the information from one place to another over to you. But the problem with quantum mechanical systems is that if I have information that I've stored in a quantum mechanical system, if I try to physically move it through a wire or send it to you by physically capturing it, I'll collapse the quantum system, because interacting with the quantum system makes it behave classically. And now you've lost your quantum information system. So there's a paradox there. How would you transmit quantum information if you can't physically disturb it and move it around physically to other people? This is where quantum teleportation comes in.
Okay.
Where what you do is you entangle your quantum mechanical system with another quantum entangled system, creating what's called a shared bell pair. And then what you would do in this case is I would give you one half of that bell pair. And then whenever I want to transmit quantum information to you, I would make a measurement on my side of the quantum mechanical system, my half, read out the classical information that I get, send it to you through classical means, which is bounded by the speed of light. And then you would be able to perform quantum mechanical interactions to your half of the quantum state to recover the quantum information that was held in my hand. And now we've transmitted quantum information instantaneously without that paradox by solving it.
I had heard you talk about quantum tunneling, and that was your initial attraction to this field. Where does that fit in?
So quantum tunneling is the ability for a particle tunnel through high potential energy sources or barriers of potential energy. And what I mean by that is this. When you throw a ball at let's say a dodgeball at the wall right next to you, it's going to bounce off, right?
Right.
If you throw any object, your wallet, whatever, let's say you're angry, that will bounce off of the wall. And the reason why it bounces off of the wall is because the wall has a greater amount of potential energy stored inside of it than the ball that you just threw at it does. And so because it has a higher potential energy, the ball can't overcome it. It gets deflected. Okay. And some of its kinetic energy gets converted into potential energy that works backwards, and it goes back into kinetic energy, and then eventually converts back into potential energy. Now let's say though that you shrink that ball down to the size of a particle. No longer do the classical physics rules apply. Now we're talking about quantum mechanical rules where quantum tunneling is possible. So what that means is that even if I threw the ball at the wall, as long as it's behaving quantum mechanically, there's a probability that the ball will just go straight through the wall as if there was no wall there in the first place, like a ghost. It can move right through it without being hindered, despite the fact that the wall has a higher potential energy barrier than the ball would. So quantum tunneling it was a theoretical prediction, but then as we started engineering transistors and we made them smaller and smaller to the point that they became a couple atoms wide, at that point, when we crossed the nanometer threshold, what ended up happening was that quantum physical rules would kick in. So your electrons would start actually tunneling through the semiconductor devices. And those were undesired effects. Yeah, and so we know that it truly does happen like this, that you can really have quantum tunneling at microscopic scales. So when I look at what is reported by, let's say, experiencers, for lack of a better term, the ability for even UAPs to conduct transmedium travel, in leaked DoD slides, they have mentioned that they can move through solid surfaces.
Right.
People will often report being, let's say, dragged through their walls or ceilings. To me, that is an example of macroscopic quantum tunneling.
Got it. Okay. So where do you go from there? You have all this knowledge of how this works, and you read the New York Times story about the Pentagon's involvement in these UAP sightings, and you started to make connections, right?
Yep.
And so I'm really happy that you're part of our community now where you can think this way. You're in your 20s, right?
Yeah, I'm 25.
You're 25. Okay. I'm not 25. I'm more than double your age, and I've been part of the UFO community since the 1980s. And
That's awesome.
it's just been dragging. It's been dragging on and on and on, same stories over and over again until recently. So you read this story in the New York Times and you start making these connections. So where do you see this going?
I see this going in the direction of, first and foremost, actually, let me take a step back before I really address it. First and foremost, I noticed that there was a tendency to name the phenomenon, right? If you will, there's a catch-all term, the phenomenon, and some people will, right? And so some people will talk about everything under the sun, really. There's so much speculation about what it is that we're dealing with: ultra terrestrials, interdimensionals, extraterrestrials, and the extraterrestrial hypothesis. Is it valid? Is it not? I realized that it's a trap to try to use names and words and immediately trying to even speculate about what it is that we should be calling what we're interacting with, these UAPs.
Yeah.
And so what I decided to do, something that I've been focusing on, and it will be the topic of my presentations at Contact in the Desert, is that I saw a need for an entirely new framework and model of thinking.
Yes.
I think that's much more important than trying to come up with words that answers the question. I think that first we need to properly develop a framework that allows us to then form the right questions, and then we can talk about answering them.
Mm-hmm.
So in that spirit, I proposed a new field of thought. It's kind of like a mix of science, philosophy, mathematics, and language, but it is its own beast. It uses its own tools, aside from the four that I just mentioned.
Mm-hmm.
But it's called Runiversic, and within Runiversic, there's three new fields of study. And those three fields, there's other ones, but three that I've proposed for now and really honed in on are locatiogenesis, anthroexology, and the final one is exomimicry. So and I'm saying those in no particular order.
Okay.
But essentially the whole idea of Runiversic is to be able to properly think about how to address these questions, right? And so I'll give you an example. Let's start with locatiogenesis. So locatiogenesis looks at, first of all, it looks at primarily what are all the places in the universe and frames of reality where life can exist. Right now, as it stands, even 200 years ago, we believed that life could only exist at macroscopic scales. People would be called heretics if they claimed that bacteria or these microscopic organisms like viruses control our bodies or affect them. And so even the top scientists, I would say, just over 100 years ago, still did not believe in bacteria, as crazy as that sounds, right? So what locatiogenesis attempts to do is it takes a combination of theoretical physics, philosophy, and biology to try to determine what aspects of the universe can support life and what would that life look like. can life exist in higher dimensions?
Mm.
And if so, what would that life evolve to be like? And that's a higher dimension question, goes back to physics. And in order to address how life would evolve there, you would need to know the biology side of things. And more importantly, once we've understood what what are the origins of life, how is it that life arose in the first place?
Mm-hmm.
This is still very contested, but if we knew the ingredients required to create life, and if we had a better physics model of the universe and the multiverse and other realities that may exist that we haven't conceptualized yet, we would then be able to conceptualize the origins of life, where we can expect them to arise, and the evolutionary path that they would take. Then we could start working backwards and ask ourselves, does this fit or make sense with what it is that we're observing as it relates to the phenomena? So that's locationogenesis in a nutshell. The next one is anthroexology. So there's, of course, anthropology, but anthroexology is the study of the interactions between humans and more intelligent organisms and life forms than humans.
Okay.
What are the relations between them? What are the frameworks that we need to look at and develop in order to properly understand? For example, if it comes out with definitive proof that we are interacting with, for lack of a better term, some form of alien intelligence or combination thereof, then how are we to study it? How should we be thinking about these interactions? What would we do? Would we have field studies? Would we try to do what Jane Goodall did? Is that even possible in these scenarios? That's what anthroexology addresses. It's looking at and trying to track and even predict who will be the next experiencers. Those are some of the implications and results that we can get from properly implementing that.
You said who would be the next experiencers. Is that what you said?
Exactly.
Yeah. Wow. How would you go about tackling that?
So there's this concept in computer science called cellular automata. And cellular automata is the idea that you can start with very simple systems, with very simple rules, where you have imagined square cells and you have some rules about how the square cells turn white or black. And those simple rules, interestingly enough, just starting with 3 or 4 rules, eventually over enough time steps, what you'll see is extremely complex emergent phenomena that is much like cellular organisms. That's why it's called cellular automata, right? And so something that I've pondered is that what if experiencers are part of this cellular automata structure, where some other intelligence is strategically, let's say, creating these experiences, whether it's generating UAP stories in the New York Times, or whether it's approaching people like Whitley Strieber, who will then go on to write books about the subject. It could be that all these so-called small, more simple interactions are being done very strategically in a cellular automata way to then have the end result be something completely complex and emergent that would represent, let's say, an entirely new society from what we think we have today.
Yes.
So for predicting the next experiencer, imagine if you could actually have an algorithm that worked backwards and understood the prerequisites for an experiencer and understood the cellular automata algorithm that's being implemented in order to pick the next experiencer. You could then predict who will be the next experiencer with some probability.
Wow. That's fascinating. That's so interesting. And is this your idea? Are there people working on this?
I have no idea if, let's say, the intelligence community is working on this, but from what I've researched, it seems to be, I'm the first person to propose this kind of structure and method.
That's wonderful. And I cut you off. I'm sorry. So I want you to continue. So that is anthroexology. And the final one is exomimicry.
Yep. And so exomimicry is based on biomimicry. There are so many interesting inventions that we've created by studying nature, and that's the act of biomimicry, right?
Right.
A couple of my favorite examples, I think, the one that, even though it's not that, let's say, useful in the real world, but it is for certain people, is when we developed certain material structures for swimsuits for Olympic athletes that were based on sharks and shark skin. There's just so many interesting applications of biomimicry. Another, actually, I would say my all-time favorite example has not been fully scaled or realized, apart from some projects here and there. But an example of a successful biomimicry is there was this architect, I believe he was in Zimbabwe, and he created this building. And the building structure was based on mimicking the way that termite dens are created. So termite dens will be anywhere from 10 to 25 feet in height, and they are very, very, very thin, almost pyramid-like structures, where they are where they'll have very pointy tips. And the reason for that is that as the sun is at its highest and it's super hot, it minimizes the surface area that's receiving the direct sunlight. And then as the sun goes down, because you have these really big slopes on the side, these angled slopes, you're maximizing the surface area of the sun as it gets colder in the desert, because where these termite dens exist, the temperature will vary from negative 20 degrees up to 23 or 30 degrees Celsius and by the time it becomes daytime again. Yet, however, inside the termite dens, it's around like 27 point something degrees Celsius the entire time, with very minimal fluctuation in the internal temperature. It's an amazing piece of engineering that's highly energy efficient and doesn't require any form of AC or HVAC system in order to pull it off, right? And so the other brilliant part is that termite dens, they sleep in the top parts of the den at night, because cool air falls and hot air rises. So they'll stay in the upper rooms at night where they'll sleep, and it'll be, because it's cold outside, the warm air will just drift up to them and keep them warm. Whereas during the daytime, they'll go back down to the lower parts of the termite den in order to capture the cool air that was trapped there. So it's such an amazing piece of engineering that these termites have figured out. So one architect in Zimbabwe decided to recreate these same principles and made an entire building that was 90% more efficient in energy usage than any other building of its size. It was massive. And so biomimicry is just so amazing in those examples. And so imagine what happens when we realize, or when we find examples of extraterrestrial or alien technology, even if it's glimpses of it, even if it's a transient signature in our atmosphere that's picked up by the Navy or by civilian sensors, we can learn so much from just trying to mimic that technology and attempting to. And so exomimicry is that concept and idea of developing new technologies that are inspired by observing UAPs or any confirmed alien intelligence.
So these are the three fields of Runeversic. Okay. Yeah. And this is something that you're working on?
You got it. Runeversic is like something that I've, I guess, invented, for lack of a better term, and proposed. And these are the three first fields that I proposed are a part of Runeversic.
So this is, you've begun this and you have people working with you. This is something that in the future that you hope to create?
So what I hope to do with this is to get people to start adopting the framework and contribute to different parts, whether it's anthroexology or exomimicry or locatio genesis.
Okay.
My hope is that eventually this takes on the same level of seriousness as any other field of knowledge we have, whether it's language or science or philosophy. This is the framework that I believe will help us truly make progress in understanding the phenomenon and any aspect of it. And so I'm starting slow and steady. I've approached very key researchers in the UAP field to start working on different aspects of Universik that include, representing their knowledge in knowledge graphs that combine AI. These are active projects that I'm currently working on.
Great. I'm so glad to hear that. Yes, because
Thank you.
Yeah, in this field, we call it the UFO community. I'm sure that I'm dating myself by calling it that. But this UAP, I don't even know what to call it. And like you were saying, why are we labeling things? And it's not accurate really to do so. So I've been hearing this same kind of banter and discussion for decades, and everybody I hear seems to be talking as though they are dealing with humans, beings who think like we do, who have developed technology like we have. I mean, searching for radio signals in the universe. I just had Ralph Blumenthal on the show a few weeks ago, and he said, he didn't say it on my show, but I heard him say this on another show. He said, that's like searching the universe for an Italian restaurant. I mean, right? So
that's a great analogy.
It is, isn't it? So for years, I've been thinking when I hear people talk about this, that you're assuming that these are human beings who are building devices and modes of transportation like we have. Those are man-made. We're dealing with something that we have no idea and maybe don't even have the language for yet.
Yep.
So to bring in new thinking, new ideas, and new physics is what we need.
One of the end goals of Universik is to eventually modify our human language, modify the way that we think and represent knowledge in mathematics and science. Eventually, I would love to see an entirely new, frankly, language come out of this. And by that, I mean, it might not even be the English language. It might be purely symbolic and hieroglyphic in nature.
Yes.
Something where the hieroglyphs combine higher level, very deep mathematics and philosophical concepts with language, and it's all just one thing. I think that would be very interesting.
I like the sound of that for many reasons. Another thing about people receiving what they call telepathic communication, I've always been very interested in what that really is, because the argument, do the visitors speak English? Well, how could they? But they seem to be imparting information telepathically. Well, I don't know that that's in the mode of language. I think it's something else. So what you just said makes sense to me. I can't articulate it like you can, but that feels right, what you just said. That the information is imparted in a completely, as Whitley would say, in a completely new way. Which brings us to our next topic. How do we get the attention of established contact with beings who are, say, more intelligent than we are? So what tools do we have to do that?
So it's a great question. It's a very prudent one, because if there is a massive technology gap, if there is a massive sociological and even a space-time gap, and what I mean by that is, what if the nature of a super intelligent being is such that they don't even exist in our space-time, that everything we define, they live outside of it and they can enter it. So how do you communicate with such a thing? How do you get its attention, so to speak? And I try to look at the example of a uncontacted civilization or tribe. And so let's say, for example, that, when you fly over an uncontacted civilization tribe, you really hope that they don't see you. You don't want to pollute their frame of thinking or thought, or create a new religion, right, in that uncontacted tribe. But imagine that as you were flying around, you saw that on their island, for example, they've created or written E equals MC squared, or they've created or written formulas that only a more advanced civilization could know, or they have invented the beginnings of some form of scientific advancement or technology, or anything that addresses even that you exist. So imagine seeing in the native language, "We know you are here," or "We know what you are." Those things would capture our attention, right? If they said, "We know who you are and we want to establish contact." Now you're no longer behaving as an uncontacted tribe that could have its ideas polluted completely, its society, let's say, corrupted by being contacted. That tribe is acknowledging that you're there and nothing has gone wrong. They haven't broken into chaos over it. That would be a lot more comforting and inviting to begin some sort of, let's say, conversation or open line of dialogue between the two civilizations. And I believe that we have to do something similar, where we have to, at every step of the way, in every turn, every corner we turn, acknowledge that this is real. Right now, we still live in a society where we can't agree on the existence or validity of another intelligence among us. And as so long as we're doing that, we are still behaving like an uncontacted tribe that's been completely sheltered from the rest of the universe.
Yes.
Right? So if we come together, if a large majority of us just say, out in the open, we agree that, okay, this is the evidence, this is the data, this is what other humans for eons have been saying about their experiences. This must be true to some extent. Let's acknowledge it. I believe that in itself would be enough to at least capture the attention of any intelligent civilization that may be visiting us or among us. And then the next thing is to acknowledge and initiate that form of contact. Part of that may be that we might not have, let's say, either the mental capabilities right now to establish contact or communication. But I don't think that's the case, and I'll explain why. So if, for example, let's say a monkey wanted to speak with us, like a monkey wanted to signal that it's actually very sentient and intelligent and wants to be treated just as seriously as other humans, what would that monkey or primate have to do? They would have to start essentially, of course, acknowledging who we are, what we are. They would have to start trying to interact with our technology to prove their intelligence. One of the tests that we have for how smart animals are, for better for worse, is how they interact with the obstacles we give them. How do they interact with it? So, for example, imagine if I gave my iPhone to a primate and they started tapping a bunch of letters and it was a coherent sentence. That would be amazing, right? This thing is clearly intelligent. So if we have that ability where, let's say, we're putting out this quantum information into the universe, where we start developing better communication technologies, that might be the most technologically prudent way to establishing contact, is if we start developing communication technologies that are able to send and receive messages with, let's say, UAPs, if they are technological craft. That would go a very long way. If we can, let's say, decipher the communication systems between UAPs or other intelligent forms, because we have the right science, that's another way of proving, and showing intelligence on our end.
Are we doing that? Are we attempting to communicate? Or are we just saying, wow, look at that?
So I think that it's a great question. I think right now we're just saying, wow, look at that.
Yeah.
And then half of us are saying, wow, did you really look at that? Like, did that even happen at all?
Mm-hmm.
Right. So, we're not enough people are conceptualizing how to build technologies to establish contact with UAPs. It just doesn't seem to be a priority at the moment. And going back to your initial point about the fact that we ascribe these anthropocentric sort of viewpoints onto these entities, if you will.
Yes.
Imagine if so we interact with the universe, and this is sometimes it's disturbing depending on how you look at it. But all of the physics we've ever created, all of the engineering we've ever created, whether it's general relativity, quantum mechanics, propulsion engineering, all of these things account for and interact with 5% of the observable universe, which is the matter world. 95% of the universe is made of dark matter and dark energy. So the very way we even sense information, phonons, photons, all of these things only represent 5% of the universe. Imagine if you had organisms that evolved in different parts of the universe or reality in general, that evolved to make sense of the other 95%. They thrive in detecting dark energy, dark matter, and communicate and build technologies using these kinds of unknown substrates. That completely would change how they would see the universe, how they would think about things, how their evolution would happen. So right off the bat, there's this huge difference there as well. And it goes back to the importance of locatiogenesis, the ability to coherently define where and how life can exist so that we can predict the evolutionary path that it would take.
Yes. I live in Chicago and I live near Fermilab. And because I studied this in college and I worked in nuclear medicine after I graduated, I've always had an interest in this field. And I remember attending a lecture there. I can't remember what year ago what it was. It was so long ago. It was maybe 2007, 2008. And it was about dark matter. See, now and what I want to ask you is, what is the difference between dark matter and dark energy? And I think I'm a little confused because of Art Bell's show, Dark Matter. So what is the difference between the two?
It's a prudent question. Dark matter is the amount of, so it's actually a misleading word because we don't know if it's matter. That's the funny thing. But essentially, when we look at the universe around us and we see that galaxies we can infer that entire galaxies and star systems are being affected and being held together by something that has gravity, but we can't see it. We can't smell it metaphorically, right? We have no instruments that can interact with those substrates. We can only infer that it has a gravitational interaction. And so we can't even be sure if it's made of matter. That's why we call it dark matter, but that's why I said it's a bit of misleading because it may not even be matter.
Is it the same as, sorry to interrupt you, is it the same as antimatter?
Great question. So it's very different than antimatter. Antimatter is the exact opposite charge, if you want to look at it like that, as matter particles. So, for example, an electron will have an antimatter half of it, or alternative, or mirror. And the cool thing is that if you had, let's say, a human body made of antimatter, and it collided with a human body made of matter, the two would annihilate, and all you would get is pure energy. Denoted by E = mc².
That's hilarious. I have to just relate this. I have a friend in the field, and he was talking about two women, but it could be two men. That they were so radically different. He would say if they shook hands, they would annihilate each other in a matter-antimatter collision.
Minus the misogyny part. That's a really funny saying, though. It could apply to any two enemies.
Right. Okay, continue.
That's fantastic. So that's the difference. Antimatter we can actually create in labs like CERN. Even regular day-to-day objects that you would not think much of generate some level of antimatter. For example, bananas. Bananas have right. They have one isotope of potassium that will eventually convert it into antimatter or radiate antimatter. So it's very funny.
We used to put the Geiger counter near bananas when I worked at university hospitals in PET, in nuclear medicine. We used to put the Geiger counters near the bananas, and the Geiger counters would go off.
That's awesome. It's good because it means that they were working. So that's awesome.
Right.
So for dark matter, dark energy. Now, that's dark matter, this unaccounted for gravitational interaction. Dark energy, on the other hand, is even more mysterious because we can't even infer or detect its effect on anything. All we know is that when Einstein predicted the universe, and what we believed for a very long time was that we could calculate the expansion of the universe and the rate at which galaxies should be moving away from each other. But when we actually go to measure how fast galaxies are moving away from each other and the expansion of the universe, there is an insane amount of accelerating expansion that isn't accounted for by general relativity or quantum mechanics.
Okay.
Imagine this. Imagine if I hit a baseball, and the baseball, I hit it out of the park, literally. The ball leaves the park, but it just keeps going up and up and up and up and faster, and then just leaves the atmosphere, right? And I'm just a regular human. And the ball doesn't stop. It just keeps going faster and faster through space. And there's all this unaccounted for energy that the ball has that doesn't make any sense. How did it get that energy? That's the universe at the moment. The universe has all this unaccounted for energy that we call dark energy.
It exists. It's there. We know it's there.
Right. Exactly. We know it's there. But we just don't know what it is.
So you mentioned CERN. Do you pay attention to what's going on there? I haven't in quite some time. Are they making strides? Is it anything of interest to you?
Certainly. One of the things that is extremely interesting was the very recent Muon experiment results.
Oh, okay.
So imagine this. Imagine if you have a family, and in that family you have four, quadruplets, right? So they're all, and imagine the quadruplets. So whether they're boys, girls, all boys, girls, doesn't matter. However you'd like to visualize it. Imagine though that we thought that they would be the same exact strength. They would all have the same, if they were to arm wrestle each other, they would always end up in a tie. That's the weird thing about this family, is that the children, the siblings, all have the same exact strength. In the standard model of theoretical physics, particle physics, to be specific, it's predicted that the class that muons are a family of, they all have the same, they have the same coupling strength, right? So they're all electroweak, and they all have the same. We thought that they would have all the same strength. And the weird thing is that the standard model of particle physics has been able to accurately predict entirely new families of particles before we would go out to discover them. And the weird thing about the muon experiments is that there is a decay that doesn't add up or make sense when it comes to the strengths. We thought they would always be equal, but there's a certain muon decay that implies that there's a difference in the strength amongst the siblings. And the difference in strength amongst the siblings is to 99.99% confidence. And so what that means is that we are fairly certain, not as certain as we would like to be. You would want to be 99.9999, six
Right.
six deviations, standard deviations. But we're quite certain that there is a violation in the known laws of physics as it pertains to the standard model of particle physics, because if the standard model of particle physics predicted that the siblings would have the same strength, and one of them actually has a different strength, then that standard model of particle physics is not the correct model of physics that we should be looking at. So the hint of new physics happening at CERN is highly interesting to me. I'm also super interested, you mentioned Fermi Labs. I'm very keenly waiting in anticipation for the results of their anti-gravity experiments, because in 1931, Paul Dirac, he was the one who predicted the existence of antimatter, right? He's one of the fathers of quantum mechanics, and Paul Dirac, he predicted the Dirac sea. He was just a complete genius, and I know you know who he is because of your background with Jung. So, and so Dirac, when he predicted antimatter, there was a lot of postulates and speculations that because it's the exact opposite of matter, we should expect that antimatter particles their gravity, the way the gravity affects them, should be the opposite too, so that there should be anti-gravity if you have antimatter particles. And so what Fermi Labs is currently doing is they're asking the question, does antimatter fall up? Instead of fall down, does it just fall up? Does it literally just go the other way of gravity? And so we're finally getting to the point of engineering physics where we can ask and potentially answer these questions.
That's so exciting. And I hope in my lifetime we get some more answers, because I really thought that we would have come further by now. And I kind of always thought that by the time I reached old age, I'd have more clarity and we'd have more answers on all of this, but it just doesn't seem like we had made much progress. I could be wrong, but with people like you, there's hope.
Appreciate it.
We have hope now.
But this was so awesome, Laura. Yeah, I really enjoyed talking to you.
Please visit the website Speaking of Jung, that's JUNG.com, for more information on everything that was discussed in this episode. There you will also find all of the previous episodes of this podcast, which are available to stream or to download for free. This episode is also available on Apple and Google Podcasts, Spotify, and Amazon Music. And it will be available later in the week on our YouTube channel, Jungian Laura. You can also listen to this episode on your Amazon Echo device, simply by saying Alexa, play Speaking of Jung on Apple Podcasts. Just be sure to pronounce Jung with a hard J. So with special thanks to Jimmy Church and Whitley Strieber, I'm Laura London, and you've been listening to a very special quarantine edition of Speaking of Jung.
Just